The purpose of this demonstration is to show that switching the roles of the explanatory and the response variable can have dramatic effect on the regression line, but it does not change the correlation coefficient nor the coefficient of determination. Now for this example, we're going to take table 4.1 about the endangered manatee from our textbook, and our textbook is David S. Moore's The Basic Practice of Statistics, the 5th edition. So we choose this table here, we take a look at the data which is listed here. Column A represents the number of boats, column B represents the number of kills. And this has approximately 30 data values. So when we look at correlation and regression, number of data points is 30. The column A, or the X variable, is the boats. Variable Y, column B, is the number of kills. Now we see that the mean number of boats and the mean number of kills are listed here. The standard deviations are listed here. And here we have the regression line, and the correlation, which is very high, and the square of the correlation, which is also very high. So what we're going to do here first is we're going to swap X and Y. And notice here that the regression line has changed dramatically. And the reason why the change has occurred is because our interpretation of the data is changing. Under the previous conditions, we are asking, is the number of boats having any explanatory value to the number of kills? And in this case we can see that there is a very strong correlation and a very strong coefficient of determination among these two variables. When I swap these two, the regression line changes dramatically, but now we're asking, does the number of kills have any explanatory value to the number of boats that are involved? And while the correlation does not change if you switch the roles of X and Y, the regression line does change dramatically. So if we switch them back and look at a scatter plot, we can see that we have the data plotted and we have the least squares line being shown already, with this being shown here. And again, if you show the mean line for the Y variable and for the X variable, you find that the intersection of these two will always be on the regression line. Now if we go back to correlation and regression and we swap X and Y and we look for the scatter plot, the graph looks dramatically different because the line is different, the values of X and Y have been switched, and in effect that reflects the graph over the identity line of Y equal X graphically. And this is why the appearance of the data plot is extremely different. And this is what happens when you switch the roles of X and Y. The correlation does not change. The coefficient of determination does not change, but the scatter plot can change and the regression line can change because of this switch in interpretation of what it is you're trying to find.